So today we're just, again, we're going to apply our knowledge of trig, our knowledge of vectors, and we're going to solve problems that makes us apply the things we've learned. Okay, and so number 12, our example number 12, gives us two forces. One is 342 pounds and another one is 454 pounds. And what they tell us about those two forces? 94 degrees. The angle between them is 94 degrees, right? So not quite how I drew it on my paper, but I probably would draw this way. What's that? No. No, the question was, do we need to have exact measurements in our drawings? And my answer would be no. And so I had 342 and 454. Okay? So number 12. All they asked us to do is draw pictures. So the 11 and 13, I think they're the same way. Just draw a picture that shows what that's representing. 454 pounds. Okay? Number 14. Sabrina, could you read number 14 nice and loud for the recorder here?
Find the magnitude and direction of the resultant vector for each diagram.
Oh, good. They give us this diagram. And so it looks like this. Oops. Let me back up. Okay? So they give us this this drawing, and they want us to find the resultant vector, right? The magnitude of the resultant vector. Well, when we did this before, we did things like this. And we want to find that, okay? I think we probably still could do that because we could find this angle and this angle, and we probably could use our knowledge of trig to find that. But it's done a little more easily if we just look at, if we don't focus on those green dotted lines, so let me move them out of the way. If instead we focus on what are the components of each vector, okay? What are the components of each vector? So we'll write them as unit vectors. So let's call this one vector 1. We'll call this one vector 2. Okay? And so vector 1, if we think of this as the xy axis, okay? What is the x component? What's the I component of vector 1? The x. How far does it move along the x-axis? 65. So we get 65 I, right? And then along the y-axis, how far does it move? This is 0. Okay? So vector 1 is very simple, just as along the x-axis. There's no y component. Now vector 2 has more to it than that. And so in order to find the I in the j, we need to look at the components. So what was this angle here?
60 degrees.
Yeah, it's actually a negative 60 though, right? Because it's going this way. Okay? And so the y component from that 60 degrees is which side? The opposite. And this is the what?
That's the hypotenuse.
And so which trig ratio is opposite and hypotenuse? Sine. So we're going to say sine of negative 60 is equal to opposite, which is y, over hypotenuse, which is 50. Okay? And so y is equal to 50 times sine of negative 60. What's sine of negative 60 equal to?
That'd be
Negative square root 3 over 2. You didn't say negative? You did. You may have been a stumbling mistake, but you did it. You said neg, and it's square root 3 over 2. So this is 50 times a negative square root 3 over 2, which reduces to a negative 25 square root 3. And that's the j component. The I component is this side right here. So which side is this compared to the, or in relationship to the 60 degrees? It's adjacent. And this is still is the, and so that is cosine. So negative, or cosine of negative 60 is equal to x over 50. So x is equal to 50 times cosine negative 60. What's the cosine negative 60 equal to?
Negative times.
Yeah, not really. They tricked you this time. It's a negative 1/2. Did I say negative? It's a positive 1/2. I didn't mean to say negative, I did. Cosine is positive in this quadrant and this quadrant. So negative 60 is in that quadrant, so it's still positive. So this is equal to 50 times a positive 1/2, which is 25. Okay? So those are our vectors in unit vector form. The question now is, how do I find the resultant of two vectors? We add them, right? We add them, and so our resultant vector is going to be the sum of these. So 90i minus 25 square root 3j. So that's our resultant vector. Question now is, what is the magnitude of that going to be? How do we find the magnitude of a vector?
Take the absolute value.
No.
Square root of the square.
Yeah. It's the square root of those squared. So this is 8100 plus 625 times 3. square root that, what do you get? 99 point,
Yep, 9.
99.9 miles per hour.
Wow. I can run that fast.
Okay.
can
I think the
walk
question
that
asked for a little more than that. I don't think they asked simply for the magnitude, but also the direction. And so, what this means is, and I left this in there, we're looking for, what is this angle? Okay? What is that angle? And so,
330.
330,
Because you take half of 60.
half of 60, well, no, that's not true.
So you go from,
If these two sides, this side here and this side here, are not the same length, then that's not going to split that in half.
Did you just say like 30 degrees east of south or 60 degrees south of east?
But it's not 30 degrees. It's not exactly 30 degrees. Okay? If these forces here are not exactly the same, then that's not going to split it in half. One force, it'd be like AJ and I with a rope pulling on Sabrina. And if AJ's over there and I'm over here and he's pulling harder than I am, she's going to go more in his direction than she is in my direction, right? If he's applying more force than I'm applying, then she's going to go in that direction. The same thing happening here. We have these two forces pulling not the same direction, and one is a larger or higher force than the other, so it's not going to pull it straight down the middle. It's going to pull it more to one side than the other side. So we have to find that. The way the book always did this is they say, well, tangent of our angle is equal to, okay? We now know this side is square root of what? Oh, yeah, I don't want to use tangent.
you use a lot of
Oh, no, I'm sorry. Let me back up. Let me pause for a minute. Okay. Sorry, I got my bearings now. I was a little bit confused with myself for a moment. But these are, quiet please. These are my X and Y coordinates of my my vector. Okay? And so what that means then is if I completed that, okay, my Y component is actually this right here,
Yeah.
okay? My X component was 90. And so the reason I want to use tangent,
So, and then we already have a 90 angle. It's like a 90-degree angle.
right, so the reason I want to use tangent is because from this angle, this is opposite and this is adjacent. Okay?
Where do you get 90 from?
Well, if you go
90 is right here. That's the Y component, I'm sorry, the X component of my resultant vector right here. Okay? And the negative 25 square root of 3 is the Y component of my vector. And so tangent of theta is equal to opposite, negative 25 square root of 3, over adjacent is 90. So tan is equal to, inverse tan, I'm sorry, theta is equal to inverse tan of negative 25 square root of 3 over 90. And so if we just plug that in our calculator, we get theta is about, probably gonna give us a negative number. What is that? 3, you have this done? Did you get anything?
Negative 25.7.
Negative 25.7. Okay, so that then 360 minus 25.7 gives me what? $334.3.
Yes, 334. Maybe that's.
No. If I look at what I've done here, negative 25.7 is this angle. So if I just subtract that 25.7 from 360, I get the other way. Okay. So here's my magnitude. Right here. And here's my. Yeah, pause in the middle there.
You saw the track when they're cleaning
Oh.
up on Friday.
Okay, thanks. And this is our angle, okay? All right. I have one more I want to go through with you. Number 20, they give us 3 vectors. They list 3 vectors and then they list their angles, okay? So they give us a 70-degree vector, they give us a vector of magnitude 70, that's 30 degrees down. Actually, they said 330, right? So 330, so I'm just going to list this one, negative 30. And then they give us one that's 40 at 45 degrees. And then they give us one that is 60, is it? Yeah, 60 at 135 degrees. So makes that one. Okay? So it looks like this. And they want to know the resultant from that. Okay, so I'm going to pause this for a minute. I want you to talk within your group real quick about this. Okay? And try to come up with a game plan of how you think we need to find the resultant of these 3 forces. Okay, come back. I'm hearing some good things. Kara, you want to recap what your statement just was?
Basically, we're trying to solve this problem like we would for 14 using tools that were given in 12.
Okay. So this is number 20. Excuse me. So we need to find the what of each of these vectors. We have the magnitudes of these vectors. What do we need to find? You said this is 40, right? And this one was 70? Yes. I didn't write them down, but we knew that. Would you say it again, Max? What did you say we need to find?
What? Direction.
The direction? Okay. Ultimately, we need to find their angles also. find what do we want to find from these three vectors given to us here?
The result.
What do we want to find of each of those vectors? I'm not asking you to find the resultant yet. Before we do that, we have to find what of each of those. The I and the j. What's that called when we find the I and the j? The unit vectors. Talking about their components, okay? Their x component, their y component. That's what we need to find. And so, this looks kind of bad, but oh well. So we need to find those two, right? And then, let's actually do that first. We'll call this vector 1. Or let's call it force 1. We'll still call it a vector, but we'll use F for force. That's the first force being applied to our situation. And so its components are, well, if this is y, this is x, right? How do I find the x component?
You use cosine.
I use cosine. So cosine negative 30, or you know what I did in my notes. Sorry, I erase all that. I just used the number they gave us. You just use the angle they gave us. Listen, you can do it one of two ways. You can do like I did before, know what quadrant you're in and put the negative sign there yourself, or you can use the angle they give you and then your calculator will give you the right sign. Okay? So cosine 330 is equal to x over 70. So x is equal to 70 cosine 330. Okay? Can we jump right to this? What's y going to equal? Sine 330. Okay? That's exactly what it's going to equal. 70 sine 330. And I guess if I clean this up a little bit, this reduces to 70 times cosine of 30 is square root of 3 over 2. So that's 35 square root of 3. Do you agree? And sine of 30 is what? But negative, 330 would be a negative 1/2. So it's going to be a negative 35. So my force vector 1 is going to be x is 35 square root of 3I minus, because it's negative, 35j. Okay? Now, if I look at this one, it is, yep. And so if I do that, force vector 2 okay, this is, oh, I see how bad that is now. They got underneath it. So this is the y and this is the x. And cosine of 45 is x over 40. So that means x is going to equal 40 cosine 45, right? Which is going to be 40 square root of 2 over 2. which is 20 square root of 2. Is that what you're saying, Alexis?
And it would be the
Okay.
same for y, correct?
And you're right, it's a 45, 45, 90, so y is the same. And so we get 20 square root of 2I plus 20 square root of 2j. And it's a plus because we're in quadrant 1 where both signs are positive.
You know what's the same with just different numbers, so it'd be 30 root 2.
Okay, now, you're saying that this one you're saying this one's the same because it's still a 45, 45, 90 also,
And you just
but
divide
we
60
have
by
a
2.
hypotenuse of 60,
Yeah, you just divide 60 by 2.
so it's going to be x equals 60 times square root of 2 over 2, which is 30 square roots of 2. Okay, and I agree with that.
For both
So this would be 30 square root of 2I plus 30 square root of 2j. And I'm glad you caught that. What are you saying?
And one would be a negative.
Yeah, which one's negative?
X value.
The x. That's correct. And that's correct. That is correct. So the resultant force is what? What do I do to find the resultant force? I add them up. And so my eyes are negative 30 and 35 is a positive. Oh, positive. Sorry. Can't add those.
Oh, yeah.
They're not both square roots of 2. So I get negative, I'm going to get 35 square root of 3 minus 10 square root of 2I plus 50 square root of 2 minus 35j. Right? So those are my components. So do you want to find the angle or the magnitude first?
Magnitude.
Magnitude.
Guess you just use that right there.
So to find the magnitude, I'm going to say square root of 35 square root of 3 minus 10 square root of 2 squared plus 50 square root of 2 minus 35 squared. I'm just going to do all that in my calculator. And to find the angle, what's the opposite side of my angle? Remember when we did unit circle, and we said tangent is, first of all, we said sine is y and cosine is x, and tangent is
X.
y over x. It's sine over cosine. Okay? And so the sine, the y, was 50 square root of 2 minus 35. And the x is 35 square root of 3 minus 10 square root of 2. And I don't know what kind of answer that's going to be. I didn't look at my What'd you tell me the magnitude was?
I got 58.6.
50 what?
58.6.
58.6? Did I have a unit on my forces? Pounds?
Yeah.
I didn't have one, but I should have, huh? Pounds. And our angle, curious what this is. I had shut this off, but if we have an error, it's because we probably didn't group our numbers together before we divided. And that causes an error. So our key sequence on our calculator would be second, and they give us a parenthesis, so we apply one. We say 50 square root 2 minus 35, divide, and add another parenthesis, 35 square root 3 minus 10 square root 2.
Yeah, I did the wrong number, that's fine.
Oh, okay. But anyway, we need to make sure that we put these in here, otherwise it's going to take this number and subtract this from it, and then subtract that from the answer. We don't want to do that, okay? All right? So 37.5 degrees is correct. Okay, today, you are doing 11 through 25 odds. I'm gonna be gone again on Friday, and so because of that, I originally was gonna plan a couple days on 8-7. But I, whoops, I didn't mean to do that, darn it. But instead, I think I'll talk about 8-8, and then you'll have Friday to get those assignments done. And then we have 3 days of review planning, first of the week.